mechanics. This video will be on superposition principle in terms of two-slit photon experiment. So this video will discuss the thing in terms of single photon and then only in terms of a large number of photons. This is in continuation of our earlier videos on two-slit experiment with an electron. So let's see. So we basically represent the photon in terms of its momentum as well as localization, that's mean position. And if we take a single photon in front of a beam splitter and there are two slits, then that particular photon have two slits in terms of quantum mechanics, and one slit corresponding to the first slit one, that is represented by psi 1, and the second one passing through the slit 2 as psi 2. So let's see the figure first. This is the figure. So slit number 1 S1, slit number 2 S2, this is the single photon coming through, and then let's see, the photon, the slit for the slits S1 is psi 1 and the slit of the photon for the slit S2 is psi 1. Now the question arises that if the beam is the photon is only single one, and since the photon is not a breakable one, single photon, we can break it. So how we can represent the photon on the screen then? The answer is the superposition principle, and it is represented by this equation 1. C1 psi 1 plus C2 psi 2, where this psi 1 is representing the probability of for the slit number S1 and psi 2 represents the probability for the slit number S2. So this particular thing is possible in terms of quantum mechanics only, where a single photon is represented by the superposition of two slits. And in the classical context, what happens is that we talk about intensity. Suppose the same photon, whatever we are explaining in terms of classical, the equation will be maybe this one, C1 phi 1 plus C2 phi 2, the same photon. But this phi 1 is actually representing the intensity while passing through slit S1, and phi 2 representing intensity passing through slit number, so that is S2. So classically, it is possible that that the single photon is divided into two intense beam, one for the slit S1 and another for the slit S2, and the total intensity is represented by phi and is given by a superposition of the two slits, where the phi 1 and phi 2 are simply intensities. And that this also represents that since the intensity phi 1 is corresponding to S1 and intensity phi 2 is corresponding to S2, that also means that in slit S1 the photon is present and in slit 2 also the photon is present. So what does it mean now? The meaning is that a single photon is present in slit S1 and as well as in slit S2. But since the photon is not a breakable one, so how this can be possible? And so we can describe the classical explanation that a photon state cannot be discussed in terms of classical, where the interference of the photon is taking place. Interference of a single photon is taking place in terms of their intensities. Intensities means one intensity while passing through S1 and another intensity passing through S2. But quantum mechanically, this situation is taken to be like that a single photon has two states while passing through S1 and S2 states. One is represented by psi 1 and another one is represented by psi 2. Again, coming back to a situation where instead of single photon we are considering a large number of photons, in that case also, we have two beams of intensities, and again the intensity will be pi square, and this would say that if we say that beam of photons or a group of photons are coming through S1 having an intensity certain amount and another equal amount towards S1 and S2, then this would mean that same number of photons are present in the two beams while passing through S1 and S2. But question is that when they interfere passing through the two slits, they are simply resulting in annihilation or maybe creation of another photons, and in that case annihilation or creation may lead to the more number of photons or the less number of photons, and we should have the energy consumption of energy. So the photon numbers will not be preserved in that case, and this will lead to the failure of energy consumption law. So classical explanation, whether it is in terms of a single photon or in terms of a group of photons, would give us no picture at all. That in terms of quantum phenomena or quantum theory, we can discuss the things that a single photon can pass through the two slits equally at the time, because the states representing passing through S1 and the state representing passing through S2 are simply probabilities. So in terms of quantum mechanics, that the single photon at the same time is passing through the slit S1 as well as through the slit S2, because these states are representing probabilities. And similarly also for a group of photons also the same condition applies, where that through a particular slit, say S1, that particular wave function will represent the probability of finding probability of passing through a slit, and the particular wave function may represent the number of represents the state of the photons passing through the slit number S1. So that partly a single photon can go in terms of quantum mechanics, but in case of classical mechanics, we cannot say that a single photon can go through two slits. It's because we calculate the classical ideas in terms of intensities. Intensities cannot be present for single photon. Intensities cannot be present at the same time for the two slits. But quantum mechanically, since it's related with probabilities, so it's possible that the single photon may pass through the slit number S1 as well as slit number S2. So a photon in case of quantum mechanical ideas is that it interferes with itself. Thing is that we take a single photon, it is probabilities that it is passing to S1 also, its probabilities that it is passing to S2. Both the states are represented by two functions, say psi1 and psi2, and this psi1 and psi2 will interfere, and ultimately we will get the photon on the screen. And the important thing is that interference between two different photons never occurs in terms of quantum mechanics, because we don't take intensities in quantum mechanics, we take probabilities. So this, as obvious, is that now there's a famous paradox which we're discussing in our earlier videos also, where that tasty food is there, but the poisonous food, while without opening a box, within a box, a cat is there. Without opening a box, we cannot say that the cat is dying or cat is living. Only thing is that without opening a box, we say the cat is dying as well as cat is living. So the two steps is possible in quantum mechanics, where taken this cat paradox into regard. So the conclusion is that classically we cannot explain the single photon or number of single photon experiment through two slits, or a number of photons through two slits, because intensities come into the picture. But in case of quantum explanation can make it possible by taking probability into account, where every state is representing the probability of passing through a particular state. So hope that this video is useful for you. Don't forget to comment and like the video. Thank you very much for watching the video.